Welcome to the Sea Engineer webinar for seismic analysis. My name is Yannick Franken and I work as Product Service Engineer for Sea Engineer. The goal of this webinar is to illustrate the seismic analysis. It is advised first to follow the webinar about model analysis, since a model analysis of a structure is the basis for the seismic analysis. And the webinar for model analysis also illustrates the build-up of the mass model of the project that will be used in this webinar. The first step will be to tick on the additional functionality for seismic analysis. Since the build-up of the mass model is already illustrated in the webinar for model analysis, we will now immediately go to the load cases. The seismic action will be modeled as a load case of type dynamic. The specification of the dynamic load case is of course set to seismicity. Also note that each dynamic load case is linked with a mass combination. The creation of the mass combination is already explained in a webinar on model analysis. Since the webinar will only illustrate the basic functionality of seismic analysis, we will only model a seismic spectrum in X. For a real project, we will also have to create a load case with a seismic spectrum in Y and a seismic spectrum in Z, and we will have to create the seismic combination of those load cases. The spectrum can be defined manually or according to code. The code parameters can be defined by the user. For an explanation of these parameters, reference is made to Eurocode 8. Apart from the definition of a seismic spectrum, there are still some other properties of a general seismic load. For instance, the type of evaluation will explain how the results of the individual modes will be summarized to a global result. The mass in analysis will explain which mass will be used for the seismic analysis. If only the participation mass is used, there should be at least 90% of mass participation in all considered directions. For an explication of the other parameters, we advise to take part in an advanced training session on dynamics. In a real project, a Eurocode combination should be made of the seismic actions in the three directions. But this is behind the scope of this webinar, so this step is skipped. Instead of a modal analysis, we will now perform a real linear calculation. The number of Ego frequencies is already set in the solver settings, and the mesh refinement is already defined in the mesh setup. In the webinar for model analysis, we have seen that in the calculation protocol for Ego frequency, we could see the model participation factors. In this webinar, we will have a look at the calculation protocol for the linear calculation. For each dynamic load case, we can see the accelerations in the three directions. Since in load case 3 we have only defined a spectrum in direction X, we can only see accelerations in X. Also note that the damping ratio is set to 5%, which is a default damping that is taken into account in the Eurocode spectrum. It is also possible to manually define damping in the structure, but this is beyond the scope of this webinar. For this, reference is made to an advanced training on dynamics. In the calculation protocol, we can also find the mode coefficients for each mode. We can also see the base shear forces and the overturning moments that the seismic action is causing on the structure. Under seismic detailed, the accelerations caused by the seismic action can be shown. We will show the acceleration in x direction. The accelerations in x are shown on the screen. Apart from the accelerations that can be viewed under seismic detailed, of course there are still some normal results for the seismic analysis, because the seismic analysis is really causing real internal forces and deformations on the structure that should of course be taken into account in the design of the structure. We are now looking at the deformation in direction x of the structure. In contradiction to the results of the model analysis, this is not just a way of deformation, but this is really an absolute deformation in dimension values. The maximum deformation of the rooftop is 2.6 mm. On the screen, the moments in the 1D elements that are caused by the seismic actions are represented. These moments should be taken into account in the design, and therefore it is recommended in a real project to include the seismic actions in a combination. We will conclude our webinar on seismic analysis here, but for more detailed information on the seismic analysis, we advise to take part in an advanced training session on dynamics.